here we are in with the students of my class on ecological construction system. And since the beginning of the semester, I have I've spoken to them about different ecological material, mostly natural material, and different systems in general. And from now, we are speaking about more in detail about case study. And for this, I had the idea to invite you because I have been impressed by the work you are doing in Thailand and all the beautiful buildings you have been building these last years. I couldn't see them in reality, but I have seen so many pictures, and I'm really glad you accept my invitation to this class to explain your work to the students. So please, well, here you are. I'm giving you the making you a presenter. You can share your screen as you like now.
Okay. Hi. Hello, everybody. My name is Markus Roselieb. I'm here in Chiangmai, and we have set up a company that designs and also builds buildings from natural materials, mainly using earth and bamboo. So I'll just start with my presentation, and as far as Mathieu said, we will have a question and answer session later. But if there are any questions, you can also ask me while I talk. I have no problem with that. Mathieu, can you see the screen?
Yeah, we see the screen really well. Thanks.
Okay. So Mathieu asked me to talk more about construction techniques, and so I will be doing that. But in the beginning, a very small thing that is close to my heart, and that is, for me, natural materials are not necessarily only an eco-freak corner of the architectural spectrum, but these materials are hopefully mainstream construction materials in the future. So what we are trying to do is we try to combine the natural materials with modern design, also with modern functionality and combination with technology. So we set up houses that look like resorts, like the one you see here, or we build buildings that have inside mechanisms that feel more like 21st century than like a hippie column somewhere outside of town. So we really want to integrate things, and our philosophy is built on connection rather than separation. We really want to connect inside and outside, as well as technology and nature, and therefore we try to use also modern knowledge in engineering when we set things up, and not only haphazard kind of, oh, this will work attitude. Everything has to be calculated, everything has to be reproducible to a certain extent. But at the same time, as you can see in these photos, we take great care of making the design a design where you want to go. You know, for me, one of the great failures of this century, a lot of the developments of community housing that are segregated, and where people build 2-3 types of houses or design on a computer, and you can buy one and then it's built. In Thailand, they have these gated communities, as they're called here too, as privately built. And if you go there on a Saturday morning, you will see 80% of the population jumping in their car and driving somewhere else where the grass is greener and it's more beautiful. But for me, that is a complete failure as an architect, because I want people on their free days to want to stay at home, because there's no better place than their home. You know, if you invest so much money, what is it for? So we really want places where people invite their friends to come instead of running away from them. So functionality as well as beauty and design combined. Okay, let's go back to what actually Mathieu wanted me to talk about. Sorry, Mathieu, for the little digress in the beginning.
No, it was really good to tell about it so everybody can understand what philosophy is behind your design and how you design your building. So thanks a lot for this introduction.
So let's go to a more practical part that will be able to bring bamboo into the 21st century, is by understanding that it can be used not only for small resort buildings or a small house on the pond or in the woods, but really also for larger buildings, like spanning a sports field or something like this. Here, this was one of our first assignments to do so, an indoor sports field that has to have baseball, a conventional baseball field size. And then we have to have, I think, 4 badminton courts, volleyball court, and several other things that have to fit in there where people can train sports at the same time. Plus, we need to have a balcony for visitors to watch, and it has to be used as a assembly hall with a stage for performances. So, a rather big space for what people think is just a normal bamboo hut. In many places, bamboo is used like this. You take the biggest bamboo you can, and then you connect them with steel and concrete connections. We talk about bigger construction. I'm not talking about small things now. The disadvantage of this thing, of this way of thinking, of this way of approaching, is that the big poles, the strength are the longitudinal fibers. So the strength of the bamboo is in compression, and also is a tensile strength. As you probably know, the tensile strength the bamboo is very high. But if you connect like this, if I pull on one side of a 9-meter pole, the force on the other end point, like with this connection, is leveraged, is many times. And suddenly, instead of using the strength of the longitudinal axis of the bamboo, we use the strength of a small part of the wall at the end, not to crack. So this kind of construction is kind of forcing the thinking of steel construction onto bamboo. And in my opinion, that's total nonsense. This is trying to force, 100 years of learning how to do steel structures onto this material, and that's the wrong way of looking at it. It's using the weakest part, the small and thin wall, as the connection part for forces, for shear forces. The biggest problem are shear forces. The loads are loads and tensile forces are easier dealt with bamboo, but the shear forces are the ones that come into play here. So what we started to do is to make trusses from bundled bamboo that are engineered. Engineered, I mean, somebody calculated the strength in terms of tensile and load bearing and shear force of the specific species of bamboo that we use for the application that it is used. In here, in this design, we build trusses that look like steel trusses, two-dimensional trusses to span this area that needed to be spanned. And all this was, as you always do, done on a computer, and you try to understand the forces that come down to the middle and how to compensate for these forces. And for that kind of work, for that kind of truss, we use a special kind of bamboo that has almost no hole. That's almost full, only fibers. That has the advantage, if you bundle it, you get something like a steel cable, mainly fibers that are interconnected. So the tensile strength and also the load-bearing strength of this is much, much higher than if you use just 1 or 2 big poles with a big hole in the middle and the thin wall, or even if the wall is thicker, it will never come close to the square centimeter amount of fibers you get with this kind of bamboo. Then we connect them, and we connect them with bamboo dowels. And we connect them with bamboo dowels along the whole length of those bamboos in different directions, and the different bamboo poles are being laid with about 1.5 to 2 meters overlap. Sometimes it depends on how many there are. If they're less, then the overlap is long, 2-3 meters. If there are many bamboos, then of course every 50 centimeter we start a new one. So as we connect these bamboo poles over the whole length of each pole, we don't have the problem that all the force goes onto a small part of the bamboo. The force goes over the whole length. So we use the strongest part of the bamboo. And we can make the bundle as long as we want. So we can reach much longer. For a normal bamboo pole, usually after 9 meters, the top part of the wall gets too thin to be structurally viable. So what you get is usually about 9-meter poles, sometimes 10 if it's a very thick kind of bamboo. But then you have to elongate it with something else, then you have to connect it there. Whereas for us, if we do this, we can go, I can make a bundle like this 20 meters if I want to, or 30, up to, what I want to build and how thick I can build and whatever. A quick part to the design concept, you have to find a design concept that works with the structural capabilities of your material. Because this is a Buddhist school, we use the lotus flower, we put it on the side, we cut it in half, and then we get also a 3-layered roof that helps with natural ventilation and also with natural light. For us, we always build a model first. I mean, not just for us, I guess all of you do the same. Here we use also bamboo, small bamboo sticks to make the model, and that also helps us understand, once the model is built, where the weaknesses of our design are and strengths. If you just take it in your hand and shake it or press it or so, you can feel the building. Then we stake out the ground according to the design drawing that you saw before. And then each truss is built around the staked out area, one by one. We put the poles down, and then we connect them, the lower part and the upper part. So for this one, I had a young Dutch engineer. His parents are Vietnamese, and he looks Vietnamese, but he was born and raised in Holland, who stayed with me for a year, and he really made a database of all the bamboo species that we use from all the universities of all over the world. There's so much research going on. If you really know how to look, you will find a lot. And he found, those species here, how strong they are in each way. And he understood what we want to use them for. So I could ask him questions like, for the lower part of this truss, how many bamboo that are this species and about 4 centimeters thick do I need? And he will look at me and say, 10. He will just give me a number. Before he came to our office, we had to guess from our experience. We didn't have data. But he just said 10, And then for the upper part, how many do you need? 12. That's perfect. Suddenly you have somebody who answers the real questions. That's where I find construction of bamboo becomes interesting, if we combine it with real engineering knowledge. And he used, computer programs, all this kind of stuff. I couldn't do that. I'm not an engineer. And many engineers think you cannot calculate natural materials because they don't have exactly even amount of fibers or so all through. But bamboo is pretty even. You can do it. So I think that was the step that changed a lot about the image of bamboo construction, because suddenly this is reproducible. If I say this hall can bear the shear forces of the 100 to 200 kilometer wind bursts that are prevailing, and I can show them why, and that changes things. as you can see here, we do use steel bands to hold the bamboo together, or here, because the bamboo dowels that we use, of course, cannot compensate for all the force that will tear the things apart. And then, because it's big, we had to use some cranes. We produced the trusses on site, and then we lifted them into place. We had some scaffolding put up first, exactly where they belong to, and we dug the foundations, and then we just slipped them in. For the foundations, we used concrete, how you call it, concrete tubes that you use for water, general irrigations or so. And we dig about a meter deep, make first a concrete foundation, put these tubes, paint them with tar against to protect against the water. And once they are in, we fill it with concrete again, so the bamboo is never exposed to the wet earth. And then you can see, and then we connect them with the bundles along the long way, and also in a diagonal way, according to what the architect said. And the great thing about bamboo is that it's just the forms that you can do. You know, the flowing curves is so difficult to do with any other material, and the bamboo will lead you to these curves. Once you start building, you will see how much you can bend it. We never use any technology. We don't use steam or anything. We just use the natural flexibility of the material to the extent that it lets us do it. And if we need a smaller arch, then we have to use smaller bamboo with less diameter that you can bend more. But we never use a big one, and then we use some steam to bend it. Why? Because once you take out the flexibility, once you make an arch permanent with steam, everything gets weaker. You want to have this force in there for the bamboo to re-expand. And if you then connect everything gets much stronger. So here you see in the section what we did. We used this big poles on the sides to create the space for the balcony, and also the space under the balcony that they use for table tennis or smaller sports. And you see here, the engineer did this kind of shear force wind simulation for us to show in the strongest wind how much it would move, because that's the strength of the bamboo. The whole thing can move without anything breaking. And then this was the outcome of the whole thing. So we use it for, as you can see here, for performances. The floor itself is an indoor sports floor with recycled car tires, and just the top layer is some special coloring, but underneath is very small pellets of rubber of car tires, so it's very comfortable to play, a little bit bouncy. Here you can also see again the bamboo that we use is very little hole. It just gives it a lot more fibers and a lot more strength. Here you can see the rain doesn't come in. We have a big opening here, but the way we designed it, the rain always stayed out. It doesn't get wet inside at all, even if we have wind. Here you can again see the openings are quite big because we needed the natural light to get in here as well as up here. But still, in terms of rain, nothing comes in. And it gives a very nice warm light from the top. And as you can see here, of course, hot air goes up and either goes out here or here. So we have a lot of natural ventilation in here, and that keeps everything cool. The tiles that you see here is also split bamboo layered with tar sheets. It's a sandwich method. So you can't see the tar sheets, but in between are tar sheets to waterproof it and also help with additional heat insulation. So inside this hall, even if it's very hot outside, it's quite cool. And since then, we have built a lot of buildings. This is the hall that you just saw, and these are all classroom buildings. And this is now the second phase where we built an international IB school. Besides the kind of trusses you saw there, we also have used these kind of V-shaped trusses. All the connections we do with bamboo dowels. We pre-drill and we put the dowel inside, and then we lock the bigger dowels with the smaller dowels from the side. So all you see here, this is always small dowels that are being used to lock the bigger guys. Everything is handmade. Then again, we use the crane. These trusses are very stable. We use the crane to lift it. And one of my foremen always has to provide for a dance before it comes down. That seems to help. And then we put it here. We use rammed earth walls as the main load-bearing agent. And these trusses go on the walls. And the V helps to decrease the space that needs to be covered between each other. And once all these V-shaped trusses are on top, then we connect it to fix them. These V-shaped trusses also through the rammed earth walls, we have two steel rods coming up from the foundation, and then we lock them here so that the uplift doesn't take away our roof. The good thing about these bamboo roofs is also the strength is built on thousands and thousands of small connections. Not one big connection has to take the whole force, but thousands of connections built like a skin over the whole building. So all the forces are always distributed. And that helps make it very strong, because that's where the strength of the bamboo is. We had big trees falling down on the roof and just bouncing off, because the bamboo is flexible, the forces are distributed, and even if a storm went through the village and all the roof tiles of the normal roof tiles fell off the roofs, our roofs just move a little bit in the wind, and that's the end. But it's not only the material, it's also the design. We saw very clearly that the organic curves that we give the roof helps with the wind. We made some square roofs with the same thing, and the wind will take them off. Besides bamboo, as I said before, we use earthen walls. We have three techniques with the earthen walls. These are called adobe bricks, and then we use bamboo strips inside to reinforce it. And we just make these adobe bricks from clay, sand, and an organic component, either rice husks or the bamboo shavings from our factory. And then we build them up. We find adobe bricks are great and easy way to do things, also the organic forms, whereas the rammed earth walls, as you see here with the formwork, the cost is in the formwork. And if you have to make round formwork or so, then it becomes even more expensive. So we only do straight walls. But as they are very strong and load-bearing and beautiful, we like to include them somewhere inside where they use as the interior design feature at the same time. And, you know, I only use manual labor. Just as with here, we only use bamboo dowels. My workers are all hill tribes, mostly from Burma. The Burmese military burned down their villages and chased them out of the country and killed them. So here's the finished rammed earth wall. And we just put in some red clay and some white things just for beauty. And in the end, they have to go over the wall to make it finer. The surface of a rammed earth wall is just very beautiful and has a strong character for a room. As you know, you don't need to put any photo up, and it just helps to make a room feel warmer or more interesting. This is in the classrooms where we put some softwood into the walls so they can fix some posters or photos on it, because the wall is so hard, you can't get a nail or a screw in there. And on top of the rammed earth walls, we use our third earth method is called wattle and daub because it's a very light method where we have a bamboo lattice work and then we fill it with earth from both sides. You have inside an air pocket, so it's a very good insulation against noise from the other side or also for heat, but it's very low in weight compared to adobe bricks or rammed earth walls. And that is again a different mix. This is a mix with long fibers. And the rammed earth walls, a different mix, is mainly stones. So each of these techniques has a very different earth mix. So here I'm just showing you some photos, but basically I think my talking time is over. Here, this is interesting again to see. We try to combine things. So this is in a university of research about chicken, how to rear chicken in a very fast way. The Thais are very good in this, and they needed a research center connected with this. So we made this courtyard style farmhouse, and here you see different ways of doing or finishing bamboo connections. The rope is really just for beauty. The strength is what we do underneath. Same here, but you have to sell it somehow. Here's how they look into the chicken rearing. So we used these windows were very ugly. So I used the spray paint artist to make chicken eyes so you can look to the chicken through their own eyes. Anyway, stories and stories. Here you see again the trusses on top that span the whole classroom at this university where they teach about agriculture. Okay, this is it for me. Matthew,
yeah.
Are you still in?
Yeah,
okay.
Of course I'm here. Thanks a lot, Markus, for this really good presentation and really interesting about the usage of bamboo and earth in your buildings. I am sure students will have questions. But yeah. Before starting, I would have a question for you.
Yes.
How do you connect this bamboo to your earth wall? Is there any connection?
When we put the trusses on the wall?
Yes, for example.
Okay, this is probably part that sort of missed when the connection was lost. We have two steel rods coming out of the foundations through the rammed earth walls that go up. And actually on the top part of the rammed earth wall, we put in a concrete layer, and then these steel rods go through the concrete layer and clamp over the bamboo to hold it down.
Okay, so you have made
then they're welded together over the bamboo.
Okay, kind of reinforced rammed earth wall with this steel connection to go to the foundation. Okay.
I mean, the rammed earth wall is not reinforced. There's really only two rods that go up on each side of the wall, and then that are welded together on the top like this.
Okay.
So it goes up and welded, and there's only on two places of the wall. The wall itself, the rammed earth wall, doesn't need the reinforcement.
Yes, this I know, but I thought when you were explaining it was like this, but now I really understand. It's just clamping on each side of the beam.
Yes.
Okay, really interesting. Yes. Thanks a lot for this explanation.
Yes, sure.
So now, if any one of you has question, please, it's time to ask to Markus about his projects and how he's using bamboo and earth. So please.
I have a question. Yes, I know that bamboos are strong against tension forces, but actually I know, but it can be false. They are not very strong, I guess, against compression force. How do you make a solution for compression force in case of to prevent earthquakes?
So I see two questions in there. First, about the compression force. Bamboo is very strong. It's higher compression force than oak, but you have to use the right bamboo. If your wall strength is too thin, then we're not talking about structural bamboo. So if you use the bamboo that is real structural bamboo, the compression force is very high. But for earthquake, the main reason why bamboo is one of the best earthquake materials ever is not just because of the compression strength, but it's because of its flexibility. You see, for this bamboo building that I showed you, this will be the last building standing in Chiang Mai if we have a strong earthquake, because the bamboo just shakes with the earthquake. That's what I showed you with this short clip from the engineer, is that it can move, and the movement for the bamboo is natural, so it doesn't get damaged in any way if the earth shakes because of the flexibility. But then again, you have to design for bamboo with its strength. If you design with big rods and in right angles, like I showed you with the previous picture, then you design to the weakness of the material. And your problem will not be the compression strength of the bamboo rod. Your problem will be the weakness of the connection. So you have to make this to make a clear distinction between the strength of the bamboo and the connection that you use.
Oh, thank you. I got it.
Thanks a lot, Markus, for this clear explanation. Anyone else has a question?
I have also
Yes, please.
I think I missed the word tashid. You said something tashid that is used for covering the roof, I think.
Yeah. There are tar sheets, you know. I think you use the same thing for rainproofing roofs. It's the same thing you use. It's made of tar. You know, tar is the same thing. Goudron. How do you say?
Bitumen.
Bitumen. Yeah, bitumen sheets. You know what you use for rainproofing roofs.
Yeah. It's bituminous membrane.
Yes.
Okay. Yeah. Okay.
Yes.
I thought that you said it is made of bamboo, so it's not, right?
No, the roof shingles that you see are bamboo shingles. It's a sandwich technique. We have the bamboo shingles, then we have a layer of the bitumen membrane, and we have the bamboo shingles and bitumen membrane, so they overlap about 3 to 4 times.
Mm-hmm. Okay, I got it.
So you are telling that your roof are made of several layers on the top of each other. Okay.
Yes.
To achieve proper water insulation. Okay.
Water and also heat.
And heat. Okay, both of them. Okay.
The second question: you don't have the second floor. I think one of the pictures I saw staircases going to up.
Yes.
You have a second floor.
Yes.
Bamboos are durable to the second floors. How can we build? How many floors can we build with bamboo? According to your experience,
I would love to have a client who assigns me to a skyscraper and put my mind to it. It depends on the client and the money they put into the project. Like this building and our trusses, we put a lot of our own money into researching these trusses and making this happen. You know, we are just at the beginning of this journey. I don't have all the answers yet, but I think in the future, you know, I don't see a reason why we cannot do the same as they do now with wood. You know, now they build 10 or 20-story wood houses. Bamboo is much stronger than wood in many ways, if you know how to build with it and if you build with its strength. You know, you have to understand the material. But yeah, I would love to build, you know, something that's 10 stories just to start with, and then see how far we can go.
Okay, thank you.
You're welcome.
There's also Ahmed that is asking a question through the chat. asking how do you deal with the humidity and the moisture since Thailand is a humid place?
I mean, it's a good question. I mean, this building, as you can see, it's open there. It is easier. For the rooms that we have, there's two ways. They either have an open space between the walls and the roof for natural ventilation, which used to be enough. So we on the side that the sun could hit the walls, we never put in windows. So the earthen walls are very good thermal insulators. The roof is too. So we can create quite a cool climate inside by preventing, just design mistakes. On the side where the sun hits the walls, we just put in bottles. So the bottles bring in the light, but not the heat. And the north side or the east side is where the windows go. They never go south or southwest. And once you have done all these things, with these materials, it stays quite cool inside as long as you have natural ventilation. We use fans. Unfortunately, in the last 2-3 years, people have started burning down the woods, and the air became almost unbreathable in this area during the months of March and April, during the hot season. So we had to close them off. And once they're closed off, of course, the rooms can get hot. So then we had to put, we have two things. We have an air conditioning system as well as a natural air system, fresh air system, where we run pipes through the ground for about 20 meters to cool off the air with a fan, blow them through a fan, blow them through 3 filters. So the air on the other side comes out clean and cooler, and then we pump that into the rooms with pipes, and we achieve a positive pressure in the room. So when you open the door, the dirty air cannot come in, and we pump in fresh air, and then we have to use air conditioning to cool it and take out but I mean, in the hot time, the moisture is not the problem. The moisture is a problem in the rainy season, and there you have to either ventilate all the time with fans and natural ventilation, or you humidify through the air conditioning system.
And are the earth wall helping also to dehumidifying the air, as earth wall can also absorb a lot of humidity?
Yes, much better than a normal room anyway. So if you compare with normal construction, where the concrete walls sometimes would start to get moldy and things, in the earthen rooms you have much longer before that will happen. The humidity in the air is much better regulated, as Mathieu said, because they absorb a lot of humidity.
Okay. Another question on the side from Alice Ada. As I know, bamboo is an open material against insect attacks. How do you protect the building from those attacks?
That's the same as with wooden buildings. You have to choose the material correctly to start with. The biggest problem with bamboo is the little bug that eats it up in its early years. But what does the bug eat? It eats the starch, the sugar that is there in the early years of the bamboo. And over the first 4 years, the relation of starch to fibers changes. In the early days, it's mainly starch, mainly sugar. And there's nothing you can do at that time to protect the bamboo, because at that time, bamboo is not a construction material, it's food. In its early years, bamboo is eaten by elephants, panda bears, human beings. It's like asparagus, right? Asparagus, if it's young, it's like soft and nice, but if it gets old, it gets kind of fibery. Same with the bamboo. So the first thing is, if you don't know how to choose your bamboo, then you're on the lost path. You have to choose the right bamboo, the right age, 4 years, 5 years of age, and then the sugar content will be a lot less, and the attacks of these little bugs will be less. And the second thing is, then we put it into a borax solution. Also standard world literature will tell you about that. Also used for wood treatment, and that basically does the rest. So even the termites or these little bugs, nothing usually comes in. You have to close off the holes so the bats don't come and live in there, and stuff like that. You have to close off things so animals don't come in to the building like mice or so. But in terms of insects, that's a pure that's purely knowledge of how to choose your bamboo to start with.
Okay, thanks a lot. It's good to know that it's like timber. You just need to choose the right species at the right time that will help to protect. Unfortunately, in Turkey, we don't have bamboo for construction yet. I'm sure it would be able to grow because some climates are really almost semi-tropical climate, but until now it has not been done and not been implemented, not been grown yet, at least not at a scale that can be used for construction. So, but I really hope in the future, maybe some of the students here, some of them are really interested with bamboo construction, as I know, they might think about it and try to start something with it.
I think bamboo is a material that will come all over the world more and more, also because it's good for reforestation. It grows fast. It secures the topsoil after you had deforestation very fast. It makes places that tend to slide and have earth slides, avalanches. It can stabilize this kind of surfaces very well. And there's not much work to put in it, and you can harvest every year. Once the bamboo is 7-8 years, the clump is 7-8 years old, every year new one will come up without you have to do anything. So in terms of investment, in terms of many things, it's a great plant. And in terms of climate, if you go to China and also Japan, they have very cold climates, and certain kinds of bamboo grow in those climates too. So I think there's definitely a way to bring bamboo to Turkey.
Thanks a lot. Is there any other question?
I have a question.
Yes, of course, Efe.
Hello, Markus. So I'm supposed to be in Thailand this month, but because of the corona, my ticket is canceled. I wanted to be volunteer in a bamboo structures to how to make it, practically in a labor way. So I want to ask this: do you know any like a project in Thailand or in the Bali or whoever, like in whatever place, is like you can be volunteer to learn or to work, or the workshops which is not without extreme prices? Do you know any kind of center or project for that?
That's a very good question. I get asked that a lot. Our problem is that a lot of our projects are commercial projects. So we are working for clients, and I have to deliver a certain standard of work. So I cannot use people who have no previous experience in those projects. If we do something inside at our company, that's a different thing, and people can come and do something, but that doesn't happen that often, right? We don't have to build things inside the company all the time. And in Bali, as far as I understand, if you go to the bamboo or whatever they're called, I know they're very, very expensive. So it's a bit difficult if you want to. It's like with anything. This is our livelihood. This is what I live from. What I'm making. We don't make great money, but we like what we do. We have fun and we make some money. And the way to establish bamboo as a credible material in this world for me is to deliver outstanding quality, to deliver more than the client expects, something that's more beautiful and stronger than they expect. And I can only do this with skilled workers. So it's very difficult to incorporate somebody with no skills. And the skill set usually has to be trained through some courses, or, like we did. I just put the money from my pocket and started building, and got some people around me and paid them and trained them. And then we made the company, and I paid for my own mistakes. That's because the whole industry is not so developed yet. I understand it's very difficult to get the experience.
Mm-hmm. Thank you.
I have a question from SG. You said, I think it's a failure if people go to somewhere else instead of spending their time at their home at their spare time. What methods do you use to make them stay? Markus?
Yeah, I'm just trying to understand the question. Now I'm getting there. Oh, you mean the very beginning when I said,
yes,
the architect, if people run away from their homes because they think another place is more beautiful than their homes, well, it's very simple. Design better homes. Design a home that people love and where they feel like I can do anything I want here, I can relax, I can work, I can study, I can be with my family. You know, the places that I'm talking about are those pre-designed houses that are made on a computer in America or Europe or Turkey and then built somewhere in Asia or Africa, or, you know, this is all total nonsense. That's what I'm saying. You have to be, first of all, you have to be more local, and second, you have to give the house a bit more than the cheapest thing you can get in order to make it a home. A home is something that has to touch your heart. A home is something where you come back and you smile that you come back. Not you come back because there's no other way, no other place to go to. That's not enough for me. I want people to go there because they love their homes. And so far with the homes that we've built, I've been invited to most of those places. There were always people around. They invite their friends, everybody comes, and then everybody says nice things about our design because they're different. Because our houses stick out, because we really think about, you know, listening to our clients, what kind of people are they, and design something for them, tailor-made. It's just a different approach than making money on huge construction. Don't give a damn about quality. Quality of life is all that counts. Does that answer the question?
Yes.
I have a question. I had some little research about you. Frank Gehry came to one of the buildings and talked with you. I read it. Do they think about building a bamboo space building or something?
Oh, well, you know, the government brought Frank Gehry to me because he was a government guest, and they wanted to show him something in Chiang Mai, and then eventually everybody who is in architecture ends up at my doorstep. So Frank Gehry ended up at my doorstep because of that. What shall I say? You know, Frank Gehry did some very interesting things. Very hard to say this thing, you know. Frank Gehry, the thing he's most interested in is Frank Gehry. Is a big guy, and big guys are not easy, so they don't really listen to anybody. I don't know. I can't say it was the most interesting conversation in my life. I can't say that. How shall I put that?
So the tour wasn't about the bamboo, actually, not intentionally about.
No.
Okay.
He saw it somewhere, and when they didn't know what to show him, he told them, come here and let's have a look at this. And interestingly, after he's been here, he designed this, he designed a house in Hong Kong that used bamboo in its design, but he used concrete to design the bamboo to look like, design the concrete to look like bamboo. He didn't use bamboo as a structural material. So I think that's too far out for him. And for the angles and for the design he does, he has to use steel. So I don't think Frank Gehry will ever come over to our side of architecture.
Okay. Thank you. I was excited about that. Can we see a bamboo structure that is well-known architect maybe? So maybe expand through the world. Okay, thank you.
You're welcome. Well, you will see famous bamboo architectures going through the world in the next 10 years or so. I'm not too worried about that. I think other architecture offices like Zaha Hadid Architects or others that use more organic lines in their design are more likely to come over and use bamboo as a construction material than Frank Gehry, who doesn't know what organic architecture is to start with. But some of the modern big offices do very interesting things where if you look at our curves and their curves, especially Sahadid, I would say, very much aligned. So I wouldn't be surprised if you see something from these kind of guys rather than Frank Gehry.
Or architect, or already young architect, or young companies already working with bamboo will become famous because of their work with bamboo. I mean, actually, your work is starting already to be famous. Maybe not all over the world, but frankly, when I think about bamboo construction, earth construction, one of my first answer is your work. So that's the reason why also I was really happy that you accept this invitation, because I'm sure you are really busy and a lot of work. So that was so nice for me, and also I'm sure for students to hear about what can be done like this and how you're doing it.
Well, thanks for your very kind words, Mathieu. I'm far from famous. We're a very small company. We just enjoy what we're doing, and we strictly stay with the code of doing rather high-end work, and try to understand what clients want. And we don't compete on price. We don't put ourselves into the cheap thing. It's an image thing that we have to fight more than anything else. Bamboo is still the poor man's material in Asia and in the countries where it grows naturally, because it's easy to cut, and as bamboo grows like a grass, so the new ones grow on the outside and the older ones are inside. It's much easier to cut on the outside. So they use the sugar guys to build the houses, and then they crash down in 2 years, or in 2-3 months the bugs start to eat it. And when they sit, they have the bamboo powder coming down into their clothes. So most Asians really don't like bamboo because they think it's terrible. They grew up with it and didn't like it because people had no knowledge how to select it. And so we're fighting this image of a poor material, of a weak material, purely by not giving in to price negotiations. Say, no, what you're getting from us is a lot more than what you get from a normal steel and concrete house. You get the feeling, you get all the positive characteristics of this material, the insulation, etc., etc. So it's a some people say tough way. It's just for us the only way to change the image is to put it very high up and not compromise on quality and beauty.
Okay. Thanks a lot for these very inspiring words. I think if we don't have any other question, we can then thanks Markus a lot for his presentation, and especially these words of telling that we should not give up on the quality and creating high-end buildings, even with materials that are seen as poor materials. That is the case for most of the natural material all around the world. So thanks a lot for this.
Most welcome. Thanks for inviting me, Mathieu. I feel very honored. I hope you all had a informative time, and you can always ask me via email if you have any questions. Most happy to help.